Welcome back to part 2. So now we're still doing the solving systems of linear equations, but today we're going to focus on substitution. So I'm going to go ahead and open that up here to example number 3. So example number 3 says solve the system using substitution method. Now, this is a new method, however, it is still a system. So let me make a couple of things clear here. We are doing the exact same thing we did in example 1 and 2. However, this time I do not have a graph to help me. So, because I do not have a graph to help me, there are other tools that we can use to help us solve these things, and substitution is one of them. Okay, now obviously you have a calculator and you are able to turn these into y equals mx plus b form. However, I want us to be really strong with the mechanical skills as well. So we're going to focus on substitution today. Oh my goodness, my pen, there it went. So sorry. So substitution and when to use it. When you can use the substitution method is when x or y is isolated and / or when x or y can be isolated. So those are two different ways for you to recognize when they can be isolated, because the question is not always going to say use substitution, use graphing. You, I'm hoping, are getting to the point where you can recognize, oh, y is isolated, I can do substitution. Or, oh, I have a graph, I can do the graphing method. So that is the point I would like for us to get to. So let's look at our system. It says y equals 2x plus 5 and 3x plus y equals 10. Now if you notice on this top one here, it is in the form y equals mx plus b. Now with that form, you have y is isolated, which is what we want. That is our goal, is for something to already be isolated or easily isolatable, if that's even a word. I teach math for a reason. Anyways, moving on. So now, watch what can happen. Because I have a value for y is 2x plus 5. What that means is, because I have a system, I'm comparing these linear functions to each other, I can take away this y in the second one and replace it with what the top value of y is equal to. Now let me show you what that looks like. How that looks on paper is, I've got to write the 3x and the plus first. You've got to write everything else on that second function, but then instead of y, I'm going to put in parentheses what y is equal to. Perfect. And then the rest of that equation equals 10. Now let me explain what just happened. So what just happened was I had y equals 2x plus 5 at the top, and then I had a singular y right here. I was able to rewrite that second equation, but now with what y was equal to. And notice I put it in parentheses. Anytime you're replacing something, you always want to put it in parentheses so that way you know you got rid of it. Now, if you look at your new equation, all you have are x's. You got rid of that double variable situation, and now you're able to isolate one singular variable. How you do that is how we've solved all of our equations. Don't call me after midnight. Okay? Ask yourself, is there any distribution? Well, yes, there are parentheses. I can distribute right there. Perfect. 3x plus 2x plus 5 equals 10. Done with that step. Combine like terms. I sure do. I have a 3x and a 2x. Remember, on this step, they have to be on the same side of the equal sign, and they are. So 3x and 2x create 5x plus 5 equals 10. Going to cross that out. Move variable. I do not have that situation because I do not have an x on both sides, so I'm going to skip that step. Add, subtract. We are going to subtract our constant. So subtract that 5. Now all I have is 5x equals 5. Cross out that a. Then simply divide both sides by 5. Perfect. X equals 1, and I'm done with that step. Now let me explain again what just happened. You were able to replace y with 2x plus 5 because y is isolated in this top one, and then from there I was able to solve for x and get a single value of x. Now sometimes your questions are nice and they just say, what is the value of x? And you'd be able to stop right there. But I'm going to push you a step further. We're going to identify the value of y when x is 1. Now this part is actually kind of selective. You get to kind of choose how you want to do this, but y'all know I will always give you the what do I call them? My tips and tricks, I guess. I will always recommend things to you to make your lives easy. So anytime you're going to plug in a value that you solved for, there we go. Anytime you're going to plug in a value you solved for, I would highly recommend choosing the equation where something is already isolated, and that is your y equals 2x plus 5. The reason for that is because I want to make your lives as simple as possible. You're already doing some pretty advanced stuff, so why not make your lives a little easier and choose something that's already in its isolated form. So now what we can do is, instead of writing y equals 2x plus 5, I can replace the x with the value we just solved for, just like that. Notice we have a 1 here, put it here. That's an x. I'm able to replace it. Now I'm able to solve 2 times 1. Well, we know what that is. It's 2, then plus 5. Therefore, y equals 7. Now, let me reiterate what just happened. You solved for x a while ago by doing the steps we have, and then I challenged you to then find the y value. Sometimes the question's just asking for x, sometimes it's just asking for y, and in some cases it asks for both. The ordered pair at which this system crosses, which you can see x will be 1, y equals 7, so these will intersect. At, always is an ordered pair, 1, 7. And this is considered one solution. I know that was a lot of steps, however, the steps were not as difficult as they may have seemed. So with that, I want you to try example 4 without me. Pause the video, attempt it on your own, and then come back when you're ready. Welcome back. I hope that it worked out pretty well for you. So it does say solve the linear system using, there's that substitution word again. But I want to reiterate that they do not always tell you what to use. It's your job to understand, oh, I have this, I can use this. Again, you're pulling from that toolkit. So whenever I look at this system, I see x minus y equals 3, and then x plus 2y equals negative 6. Now, substitution, the goal is to already have something that's isolated or choose something that can be easily isolated. And in this case, x minus y equals 3 is the one that we can manipulate. That would be the easiest one. Now, I'm going to challenge you again. I'm going to rewrite this. X minus y equals 3. I'm going to do something absolutely crazy, and I'm going to isolate the x this time. I'm going to put y on the other side, just like that. So then I have x equals y plus 3. And again, my reasoning for doing that is because if I had isolated y, I would have had to subtract x and divide. I didn't want to do all that. Mathematicians are lazy. We want to do the least amount of steps as possible. So I instead added y to both sides, and that's one singular step. Now, x is isolated, so this time, instead of replacing y, I actually get to replace the x. Now, how we do that is, again, we have to be very strategic. We're going to take our second equation, and instead of x, I'm going to put what we got for x, but I'm going to write it in parentheses. Don't forget your tools here. You've got to make sure you write everything in the correct form. So now instead of x, I have y plus 3, and then plus 2y equals negative 6. Now I can set this up with a don't call me after midnight. I do have distribution. I have this plus sign. I'm going to distribute it there. So rewrite y plus 3 plus 2y equals negative 6. Done with that. I do have terms to combine. I have two y's on the same side, and then those will become 3y plus 3. Oop, I wrote that in the wrong color here. Gonna go over that. Sorry, y'all. Equals negative 6. So I'm done with that step. I do not have a variable to move because I do not have one on both sides of the equal sign. I do have something to add or subtract. I can subtract. Oh my goodness, I cannot get my life together. Subtract my 3. Y'all are probably laughing at me. Then I have, oh, I almost did it again, y'all. What is wrong with me? 3y equals negative 9. Then I can divide by 3, divide by 3. Y equals negative 3. How crazy is it that you are allowed to also solve for the other variable? Now, from here, you could stop if the question said, what is the value of y? That'd be great. But life's not that simple sometimes. Sometimes they're going to say, well, what's the value of x? This is when you have to go back to your old handy dandy. Plug in a value. Just like that. Again, I always recommend choosing the easier equations. So the easier one is x minus y equals 3. And whenever I choose an equation, I do tend to go back to the original versus what we changed it to, just so I can make sure that I don't mess up anything along the way. So we're going to plug in. We've got that x. I'm sorry, looking for my pen. Sorry. We've got x, but that's what I need, so I'm going to bring it down. Minus, because I'm plugging in, I'm going to put it in parentheses. Negative 3 equals 3. Oop, rules of math. I'm not allowed to have this. I must change it. Negative and negative will make one big positive, so I can rewrite that as x plus 3 equals 3. Subtract 3 on both sides. And this is always the funny part. Y'all feel like you can't get 0 as an answer, and you can. These intersect. At 0, negative 3. And this is a 1 solution. Just like that. So I hope that this video helped if we were struggling with anything. and I will see you in the next one.